Hi, I'm Tom Corcoran, the Principal AI Specialist with Red Hat. Welcome back to our series of demos and a use case featuring AI/ML-based image recognition from the edge to the cloud. In this video, we'll show you how to set up the real-time inferencing demo. The instructions and all of the code necessary are available at this location, and this particular location with the docs folder contains the documentation that we'll be using today to guide our demo. To save time, I previously set up the demo. Let's go across and see those documents. So here are the different documents. We've actually set up our docs for a administrator classroom situation where the admin sets up some things ahead of time and then the students in a classroom do the rest. Because we're setting up everything from scratch, we'll basically be running both of these. All right, so let's take a look at our first one, which is the admin setup. Let's walk through this and then we'll show you what we've done on OpenShift itself. Here are some prerequisites. You need to install some command line tools. This is the tool to interact with Kafka. This is the tool to interact with OpenShift. A couple of other ones like JQ. Here's a Red Hat account that you'll need. Go there, sign up for a free account. You'll need an OpenShift cluster. If you're a Red Hatter, you can use RHPDS, or if you're a partner, you can use that too. Otherwise, click this link and you'll be able to provision an OpenShift cluster. First thing you'll do is download the code in the docs and do that inside of a terminal just by pasting what was in the docs, which I didn't do. Copying and pasting. I'm not going to do it here because I've done it already, but run those three commands in the location that you want to pull down the code and the docs. And you install a couple of operators. Kubernetes operators are encoded knowledge from actual human operators running inside of a container. They do things like the installation, the ongoing maintenance, upgrade, backup, recover from failure, configuration of applications. They radically simplify running applications on Kubernetes. There's two such operators that we'll need. The Open Data Hub operator, which is going to contain some data science focused components, in particular Jupyter notebooks that we'll use in a later video to train our model. And the second one is Seldon, which is an open source component that wraps an AI model inside of a container and exposes it using a RESTful API, making it very, very simple to consume. So to do that, you go to your OpenShift cluster, log in as an administrator, go to choose the administrator view, go to operators, operator hub, and first filter on Open Data Hub. Follow the instructions that are on that GitHub document. Very simple. Basically, just follow the defaults. And similarly with Seldon, choose the Seldon community operator. You can see both have been installed previously by me. Next thing that you will do after you've installed those operators is you need to copy your login command. So to do that, you go to your top right hand side, you go copy login command. You follow the defaults to log into your OpenShift cluster, and then it's going to present a token here. So you just copy that and then paste that into a terminal here. Now, in your terminal, you'll be logged into your remote OpenShift cluster, and then you can begin working. Then you create a new project and you remove resource limits. This is for a later video where you're going to be training the model. Again, you copy out of here and you paste into your terminal and hit enter. So it's going to remove some constraints on CPU and memory by deleting the limits. If any such limits exist, certain clusters will apply limits. All right, so you can allocate enough resources. Generally, we find an M5 4x large machine is enough for what's required. Yeah. Okay, that's the admin setup. Let's move to the actual work setup of the demo. The second link here, this inference demo here. This is what we've been over before, some prerequisites. First thing you're going to do, really, you've done this already, is run this particular set of commands here inside of your terminal. And then you hit enter. What that does is it's going to set up and provision a Kafka cluster running on the Red Hat cloud, freely available to anybody. It's going to set up, it's going to log in first. It's going to prompt you on the screen to log in using your credentials. And then it's going to do a few things. It's going to create a Kafka cluster, create a topic where our producer application over on an edge-based producer application that's going to take the images from your webcam. It's going to push those to Kafka. It's also going to do a little bit of text substitution for your credentials, because it's going to set up a service account, which is effectively an ID and password to interact with Kafka. So it's just going to basically run through, by running this particular shell script, it takes about 5 to 7 minutes. It's going to configure all your Kafka for you. So the only thing you'll need to do is, when that's complete, 5 to 7 minutes later, copy these 6 lines, as I've done here, into a text file. So just simply copy and paste out of the terminal, paste them in there, because you're going to need them later. Then you can look at these docs here, but they're effectively describing some text substitutions that's done for you. Log into OpenShift, you've just done that a second ago. Then you need to, on the command line, we're not in a workshop, so we need to create a new project called a producer. So I already have it, so I'm not going to run it, but you go ahead and run it. And then you'll basically do some configurations here, or you'll set up an application running at the edge, container-based application. In our case, it's running on the same Kubernetes cluster for simplicity, but in the real world, it would be probably located in a different place. Could run on a local Kubernetes cluster at the edge, or in a lightweight Docker or Podman environment. Either way, that can be done. So to do that, we'll switch to the developer view. We go ahead and add import from Git, supply some things here, Git repo URL and context, call your name, application and name producer, click on the deployment, the bottom, and add 3 environment variables. So simply what you do at this point is copy these values out. So Kafka broker URL and the value, enter Kafka broker URL and the value, and the same for SASL username and password, and then click create. A few minutes later, you're going to have a producer application at the edge. It's gonna, so we should be over here. Go ahead and add. Well, let's select our producer application. we need to have this selected. We import from Git, follow all those instructions right through, as I've just walked through. Very simple, just follow them precisely. You'll end up with an application, a Node.js application, whose URL you can hit by clicking on this button here. And then it'll ask to get access to your webcam. I have 2 webcams, so I'm going to give access to this one. Don't click start yet, but you can see that it's capturing me inside of this application. Okay, so now what we're going to do is install a few components that are on the central Kubernetes cluster running on AWS. So in fact, what I should do is just show you what the Kafka.sh did. Console.redhat.com Kafkas. This basically is going to require me to log in here. And by running that Kafka.sh, it will create a new Kafka instance, Kafka cluster called Kafka Rocks. It will also create a topic in here called video stream, where we're going to be pushing from our Edge application, the one that we were just set up. Then we're going to be pulling from it here inside of our Kubernetes-based server application. This is a controller that for every image that it pulls off the Kafka topic, it asks this AI model what that is, be it person or background. It returns back, the AI returns back a prediction, and the controlling application keeps account of the number of times that either person or background have been selected, and writes each one, increments each one out to the S3 object storage. Then we have our dashboard application later that's going to be reading that. So right now we're going to set up the controller, the AI, the storage, and the dashboard application. So let's go back to our docs. So first thing you do is new project, a dashboard inside of your terminal here. Hit enter. I'm not going to do it. I already have it. Then you go apply the Seldon. So this is the component that wraps the AI model inside of a container, exposed using a RESTful API. So you'll paste that in and hit enter. I've done it, so I'll need to. Then we're going to install our storage. Similarly, paste that and hit enter. And then our controller application, we're going to install that in the same way. That's this one here. So just paste that in again and hit enter. And a few minutes later, your application should be set up. Finally, we need to install our dashboard, and that's a very similar process to what we did with the producer application. It's going to our developer perspective, hit add from Git, enter the URL, the context directory dashboard, enter dashboard as the application name and name. Click on deployment and add one environment variable, Minio URL, and just use this one here. Hit that. A few minutes later, you'll be able to open up the route, and you'll see all of your running components over here, and then you'll have your dashboard here available. So if we go across to OpenShift, we already have our producer here. And if we choose our dashboard project, You can see here we have our controller, our Seldon-based model, our storage, and our dashboard are all running. Open up the dashboard, and our demo is going to be ready to run. Let's see, is there anything else? That's it. We've now completed this setup. You can tune in to the next video where you'll see us actually running the demo, where we're going to take the images in real time from our webcam, send via Kafka, ask the AI, and display here on this dashboard what's happening in real time. So tune in for that. All the links are in the description. Thanks for watching. See you soon.